How do we measure impact in the age of AI? If you're a software engineer, there's nothing that scares you more than somebody mentioning lines of code, but this has been around forever, right? This is a post from 2008 talking about lines of code as a metric of project complexity. And this is a common thing. When your non-technical manager is asking you, what the fuck did this guy do? There's a limited amount of metrics that he can really look at without knowing the full context. This article here from Alan McGregor, Canadian by the way, discusses how lines of code are back, and it's even worse than before now that we have AI. And he goes on to discuss how this metric has been around since freaking ever. Dijkstra, of all people, I think we all know Dijkstra from our college algorithm class. He's quoted as saying it's a very costly measuring unit because it encourages the writing of insipid code. I'm sure somebody's going to say I mispronounced that. And from Alan's perspective, he argues that lines are a cost, right? A spend. He also mentions how Bill Gates compares measuring programming progress by lines of code as measuring aircrafts by their weight, right? How absurd is that? Now, I will say, I think this is a little bit off, right? Because if we think about airplane weight, there is truly no marker of complexity when it comes to the weight of an airplane. I mean, this thing could be miles long and have, cinder blocks inside of it for all you knew. Technically, you could say that's the same for a code base, but I think it's a little bit further off from that. This article here from 2008 that we were discussing, which oddly mentions flying and crashing, kind of akin to the airplane. Anyway, Stefano argues that lines of code can actually be a decent metric for solo work. And I think really the reason for this is because you have a frame of reference, right? If your manager knows you really well and knows other projects that you've worked on, and he knows exactly the lines of code that you produce, he could potentially look at something like lines of code and have a really rough estimate, right? If John Smith wrote a feature that wrote a low complexity feature that's 100 lines of code, and then he wrote one that was high complexity and it took him 1,000 lines of code, assuming this manager knows the weeds, maybe he could look at this number and kind of get maybe a rough estimate of, this article's mentioning, hey, this leads to rough estimates for a one-man army approach. A small project of 1,000 lines can be done in 1 or 2 weeks. An average complexity project of 10,000 lines could be completed in 2 or 3 months. And a large project of 100,000 lines requires a couple of years. Now for context here, I think it's kind of important for your own understanding, I guess, if you're not familiar too much with code bases and scale. For reference, the Linux kernel is about 40 million lines of code as of January 2025. Chromium is about 50 million lines of code. And so when you look at this, your brain should be going, holy shit, Chromium is more lines of code than Linux? What? Your brain might think this a little bit. But, there's a lot that goes into this, and this is part of why LOC is always considered kind of a bad metric, right? There's the language that's being used. There's also just scope, right? Linux has a different scope than Chromium. It's got, driver code and cross-functional components to it. And so if we're asking the question, why is Chromium more LOC than Linux? I think it can boil down to these two, but then also, you have to realize Chromium is a front end and back end effectively. Obviously, when we're referring to back end, I'm using this term a little bit loosely, but when I think of Linux, right, I'm thinking of something that's really under the hood. A lot of the code is under the hood. It's the kernel, whereas Chromium is basically a combination of these two, and so that's worth considering. Another thing to realize is that Linux is largely just drivers. A lot of these drivers you don't even use, right? So if you look at the total lines of code, 40 million lines of code, you are likely not using majority of it, right? When you start your computer up and it's running its system. And a lot of driver code isn't even that dense. And a lot of these drivers are only like 500 lines of code, or really not as insane an amount as you would think. But honestly, at least from my perspective, I really cannot tell why Chromium is so many lines of code. There's probably a reason for it, and maybe somebody in the comments will have an explanation of why Chromium is so many more lines of code. But really all this tells me is lines of code is a shit metric, right? You can look at something like Linux, which you know for a fact is tried and true, used pretty much everywhere, super complex, and yet it's not as many lines of code as Chromium, which, Chromium is complex in its own right, but certainly the line of code metric is hard to use here. I think as we were discussing before, you can kind of gauge from a person how much lines of code they can produce based on the complexity. But, obviously this isn't exactly, of course, right? 100 lines of code, maybe that's 10 hours spent trying to figure out how to get that 100 lines of code. I'm definitely not agreeing with lines of code here. I think it's a shit metric, definitely. But there is something to be said about its use case. Now, this is pre-AI. John Smith had a bit more of a metric we could look at pre-AI that said, hey, he does this for this many lines of code. But now with post-AI, it is a whole different ballgame, right? Post-AI, this John Smith over here, we really have zero clue what the hell went into these from an AI tool. Alan goes on to say, the industry has really used lines of code as a productivity measurement. And even in AI, you see it thrown around a lot. Like here's a tweet from Greg Brockman earlier this year where he's calling out, 3 million lines written over a week of continuous agent time, as if this tells us anything, right? I envision a case where all 3 million lines are just this, just repeated over and over again, and we're just going to call this a metric of success. And this is to show, right, this is still a valid or a metric we see thrown around. Even the Cursor CEO mentions 3 million lines of code across thousands of files. And then here's a funny post from Test and ProdCap. Claude Code is only 500K lines of code. Gary Tan could have knocked it out in about a week. All this shows you just how much weight lines of code still carries for whatever reason. And then of course we have Obsidian Capital with the 69 million lines of code. What a god. And so it's kind of unfortunate, right? Because back then, pre-AI, you did have at least a little bit you could get out of lines of code, right? You can kind of compare the works of somebody and get a guesstimate. But now it's pretty much impossible to guess with lines of code. However, one argument I can give, and I believe, is that lines of code is still a rough complexity estimate. Yes, it is not going to tell you the whole story. Absolutely not. But if somebody comes to me and says, hey, 100 lines of code, anyone who's programmed before can look at this and just know for a fact, could read this in a day and understand it pretty quick, I think. 100 lines of code. Yes, there might be some complexity in that, right? It might have some APIs it's calling and maybe some cross-functional elements. Maybe it's like many files, right? We could have 100 files or something crazy. But for the most part, you can look at this and say, okay, this is probably not going to be too crazy. Whereas if they came to me and said, hey, 100,000 lines of code, right? This is making me realize, okay, this must be a production code base at this point, right? 100K lines of code. If you have 100K lines of code and it's not, then I'd be questioning. But either way, right? If I scan through 100 lines of code, I think I can get a pretty rough estimate of what's going on within really like 10 minutes. But if I'm looking through 100,000 lines of code, I know for a fact this is going to take days, right? This is going to take a long time, if not weeks, months, years, depending how this is going. But really, this just gives you a rough estimate. So if we're, the manager, even today, we can kind of get an estimate of how much, not at a good level, but we can get an estimate of, did they do anything, right? If I find that you've only done 100 lines of code, this may have been valuable code, don't get me wrong, but it's like this does give you some idea of the complexity. And so I don't think this is a good metric for measuring performance, but I do think it's a good metric for understanding the work involved with getting into a code base. And Alan goes on to discuss why it's not a good metric for performance. Right, he talks about how it's pretty much a gameable thing. If your manager was prioritizing lines of code, this is going to be you, right? You're going to be spamming every prompt you can and going out of your way to make sure that you get the lines of code. You could send a prompt like this. Make it as complicated and high LC as possible. I don't think anyone's tried this. I hope no one's... This may have been the single prompt that has never been sent to an LLM before. But maybe, and you would end up with extra lines of code just that way. But then the question becomes, what do we measure, right? If we're the manager, because at the end of the day, we need a way to track people. And let's be honest, managers are lazy, marketing people are lazy. They don't want to know the nuances. And I don't blame them, right? You can't, here's the thing about lines of code. How am I to know that this 100 lines of code is effective and important? Right? This doesn't tell me anything without more nuance. I need more detail. I need John Smith to tell me what kind of impact this has. But to find this out, man, we got to go and ask them, right? The skip manager isn't going to see that. Skip managers are not going to be able to see this impact. I mean, I guess if your manager's good and he's, making it clear, which he should be, but on a surface level, they want something they can look at on a piece of paper and say, hey, something must be going good here. And so let's think about the possibilities. Just off the top of my head, right, I'm thinking, okay, acceptance rate. Right, how many times has your code been approved for production? I think this is probably a better metric than lines of code because it can show that, hey, you've gotten vetted changes in, but it really doesn't measure impact. Right? Are these just a bunch of comments that we inserted? Are these acceptances into a feature that's being touched by a lot of places, or is it kind of just our own specific realm? right? There's so many questions that would go into this, but I think it's okay, right? If I was going to rate this as a metric, I would say okay, right? We need more information, but it's a single data point that we could add up. And then number 2 might be business impact. This one is extremely hard to measure, but there are some ways you can do this, right? A lot of teams have tracking, so like they'll track bugs, issues, and features, and all this. Some of the tracking can help. So if you're getting a high acceptance rate, and these are for things that are high impact, then that helps you there, right? So we could view this as like a customer scope thing, where it's like, hey, this person has submitted code that impacted a lot of users, whatever. This can kind of be gauged, but not reliably. This alone is so hard to gauge. And so I would say, personally, I would consider this a bad metric, and I don't think it's really trackable as much as acceptance rate would be. But if we combine these two, it can be a little bit better, right? So the point is, every data point that you capture adds up to being a whole story. So lines of code on its own doesn't tell you much, but if you also include things like acceptance rates and business impact, however you can measure that, whether that be through impact level, direct customer feedback. I think there's certain features that companies know are more impactful to customers, and so they can point to that. And so really, in my opinion, you can never tell the whole story with one metric. I really don't believe as an engineer there's a single metric you can look at and say, oh, this person's a good engineer. Unfortunately, the truth of it is you have to weigh in a lot of things to get an accurate assessment. Something like completed PRs, lines of code, business impacts. Each of these add up, and then eventually you end up with kind of a rough estimate of performance. And so Alan gives his own take on what to measure, what he believes is an effective way to measure. He argues that an important part is the time to value, which is effectively to say how long did it take to implement a requested feature into production. To me, I don't think there's a lot of issues with this where, if we assume time to value as a metric, I think there's a lot of things that are out of your control as an engineer that would impact this. Typically, there's peer review processes for getting code submitted. Depending on the company, you often have, roadmap prevention, right? It's not like, oh, we made an update, let's just release it, right? There's typically release schedules, and so that can get in the way. Plus, what if you're backed behind like a validation team and you have to wait on them? There's just so many areas where time to value could potentially be an issue. But I do think I understand where he's coming from with this. I think this is a case where it alone would not tell a whole story. And I question how you would measure the value part. Bill Gates came to me and said, hey, I want vanilla ice cream, which actually this would be one of the most sane things that Bill wants. And this, from what I've heard, it's more clear that if I were to deliver him that vanilla ice cream as a company, yeah, this could be a big impact because I know he's rich as hell. But it doesn't work like that in a regular product, right? Just because 100 users are asking for a feature does not necessarily mean these are high impact 100 users. These could be users that are barely using your app and they just drive by, gave a feature request. They used your app for one day and they're like, oh, I want it to do this thing. Typically, there's users that use your app all the time, and there might only be 2 people that request a feature. But guess what? These people spend the most money on your app, and this feature is actually the highest ROI that you could possibly introduce at the time. But you wouldn't know that, right? You can't always gauge that from anything, really. The other thing he calls out is code half-life. Kind of what I said earlier about Linux, how there's a lot of code that's been around since before you and I have probably been born, depending how old you are. A lot of code that's just been sitting in the dusty dungeons forever. I also think this is really not a good metric because of the fact of agility. In fact, I would say if the code that you wrote never gets changed, I mean, it depends on the kind of the timeline of the product, I guess. If this is an early stage product, I would suspect that you write a lot of code that stays forever, right? When you're building your core product out, I would hope you're not going back all the time. I mean, yeah, you're definitely going to make changes to this stuff, but there's certain things that are core to your design that you flush out really early to where you don't need to change it all the time. As you get further in your timeline, typically the features you're adding are less stood the test of time. The features you work on early on in your product tend to stick around for a lot longer. The features you work on later are a lot more reactive often. And so these reactive features, although they're important to the app, and they are important to business impact and user growth, just because they're changed all the time doesn't necessarily mean it's a bad thing. So that's a tough metric there. Kind of harps on how AI code is often revised a lot faster. To me, I don't think this really is needed for this argument. I was kind of hoping he would stay away from that and focus on the metric use case itself. But he also highlights maybe defect origin rate, what percentage of production defects track back to AI-generated code versus human-written code. And so this is really him harping specifically on AI, because some of these are really... Did you go this way with this article? Now, he does say here, which is something I think is worth calling out. He calls out that good metrics measure what happened after the code was written. And so he's arguing that good metrics are what come from after coding, and then bad metrics are what come during coding, right? So bad would be lines of code, acceptance rates, whereas good would be something like code half-life and time to value, like we mentioned before. I do think he has a point here. I really do. I think if you were going to look at the whole picture, I'd rather take these metrics and kind of combine them to understand the value versus this. But the problem here is, unfortunately, if Greg Brockman came up here and said, hey, we have two acceptances to PR over the week of continuous agent time, it just wouldn't sound as cool, right? And it doesn't give you any idea of the code base. And so I get what he's saying here, but I think if I was comparing AI to human, I think these are all kind of tricky, and you really need more than just one of these to have a full picture, right? You can come up with arguments that say why half-life is a problem, time to value is a problem, and you can also say the same for during coding. But as a manager, what are you going to look at? You're going to hopefully look at all of these. I think you can't look at a single metric and say that this is their value. And this is part of being an engineer that nobody really talks about, is the fact that you really have to sell yourself, man. You have to sell these metrics in a way that makes you look good, right? Because if I just look at your metrics on blank and I see, oh, X lines of code and this many completed PRs, this many business impact, whatever. Especially with business impact, you have to sell yourself, right? There's a lot of times where people that really didn't do much on paper, right? You look at their lines of code, their completed PRs, all this stuff, it's really low, but because they're able to sell themselves well, it ends up resulting in them with a much better performance at the end of the day. Because if I'm a engineer and I only wrote 100 lines of code, if I go to the manager and I bring the business impact and I bring the story of this 100 lines of code, this will change his perception on that entirely. And so I think, a manager, ideally, they want this easy metric like lines of code, but unfortunately, they need more context, and you as the engineer have to deliver that to them. There's this article here called Sell Yourself, Sell Your Work, and it really highlights the importance of being vocal about your work, right? You could be in a basement coding up freaking God's hand that's going to save the entire universe. You could be coding Thanos' freaking glove. But if nobody knows about it and nobody understands its impact, it's nothing. And he goes on to say, right, it's in short, you have to advertise. I've dealt with any number of technically brilliant people who produce outstanding work. The majority of them never bothered to write down their work and communicate it to others. Report writing is too boring, uninteresting, and hard, and irrelevant, or so they thought. Right, I'm guilty of this when I first started my career off. I would often put a lot of work in, right? I'd be, hammering out PRs and all this, but I wouldn't keep track of it. And so when the time of the month came, the performance report, when the company's asking you, hey, tell me what you did throughout the quarters. At least early on in my career, man, I pretty much just went off my memory at that time. And so I would write all this stuff out. But I think when I was early in my career, I kind of had the assumption that my manager just knew about it. But you have to realize, dude, managers have a lot of reports, especially in certain companies. It depends on the company, but even, let's say you have 3 reports, so you have 3 people that are reporting to you. This is a lot of people still, right? You have to realize the manager has a lot of shit going on with their job and life and career. And it's hard to remember and picture everything that everyone on their team is doing. Obviously, a good manager is going to get this out of you, but not always, right? Some managers are not good at selling their employees. And so it's really on you to make sure that you're keeping track of this stuff throughout the quarter and getting good at selling it, right? It's an annoying part of the job, don't get me wrong, right? When all you've done is written 100 lines of code of a low complexity feature, you do not tell them this, right? You don't say, oh, it was an easy work. You make sure to sell what this is doing, right? You don't say, oh, it was a low complexity feature. You say, hey, this thing saved stability, right? Our uptime went up 10% since I introduced this freaking thing, right? Obviously, you should make sure you're realistic in your claims, but you really do have to sell yourself. And it goes on to talk about, a lot of people, they make their own startup because of this reason, right? They're high performing, but they don't get their recognition and progress in their career And so they're like, hey man, I'm just gonna take this freaking talent that I have and, and start my own business. I go down to freaking Weenie Hut Juniors instead. But you have to realize, man, really to be successful in startups and things of that nature, you have to be good at selling anyway. The skill of marketing yourself, it extends to everything you do in life. He quotes from Richard Hamming, "It is not sufficient to do a job, you have to sell it. Selling to a scientist is an awkward thing to do. It's very ugly and you shouldn't have to do it." You know, it kind of talks about how you expect that the world is just waiting on you to do things and is fully locked in on what you're doing. But unfortunately, everyone is busy with their own work, right? Nobody has time to keep track of what you're doing, right? And you can practice this yourself, right? Think about anyone on your team that you view as a high performer. Can you list off everything they've done in their entire last week even? You cannot keep track of other people like that. It's just not possible. And so really, I believe no metric is good enough. I think really every metric is good enough if you sell yourself the right way. I think even lines of code in this day and age is still used as a selling point. It's unfortunate, right? Because I think engineers, we view it as a really bad metric. I think it has its place. I think it's good for describing the complexity to a rough estimation, but it definitely is not a good metric for measuring the performance of a person. I think to sell the person, you really need more than just that metric, and ideally, they need to sell them on it. A good marketer can sell 100 lines of code as if it's golden bars from RuneScape. A person that's bad at marketing themselves might sell something they did that was highly complex as basically useless. And so you have to sell yourself. You have to get really good at marketing the things that you're doing at your company. And if you have a really good manager, I think you can bring this to their attention. I've always made an effort, especially early on in my career, to actually ask my manager, like, how can I market myself better? Oftentimes they'll give you good advice on this because they actually understand what the higher up is looking for. At the end of the day, ideally, most companies, the manager's there to help you. And so I encourage you to ask these kinds of questions if you find yourself not too good at it. I don't think it's a thing where you can just read a book that's going to tell you how to sell yourself. This is really something that comes from practice. And I know a lot of us have, imposter syndrome. And so we think everything that we did is just not that important. You have to ditch this. You have to ditch this right out the gate, man. If you want to succeed in tech, you need to assume that everything you did is a God's given gift to earth. Even when it's not, you need to kind of sell it that way. Obviously, you don't want to go around saying, hey, everything I did is high impact. But at the very least, try to make it known that everything that you do has a rhyme or reason to it. Realize that we have people using lines of code in marketing and are successful with it. And so you don't need a specific metric. You just need to be able to sell that specific metric. And I don't think we'll ever find one metric that can do so. I think it's always going to be a culmination, and I think it's always going to be based on the engineer's ability to sell themselves at the end of the day. It could be lower on all these metrics, but because you manage to deliver it in a way that seems more important, people are going to perceive you as a higher value engineer just because of that.